Okay, so it says rewrite each equation in exponential form. So remember, you start with the base. So you have 7 to the third is equal to 343. All right, this time we're going from exponential into logarithmic. So we know we have to have a log. Start with the base. So log base 18 of 324 is equal to 2. All right, now we're evaluating. Okay, so, all right, some of these you could do in your head, like this is like 7 to what power equals 49, so obviously the answer is 2. All right, but you could grab your calculator and get a log with a base, so alpha window, option 5, and then you can just put down there 7 and then 49, so you get 2. Okay, so the answer to that is 2. So if it says just to evaluate and you're just supposed to know what it's equal to, just put it in the calculator. So 4 is just like that, all right? And so is 5. So if you pull up your calculator, number 4 says log base 4 of 68. So log base 4 of 68. And we're just going to round to the 100. So that'd be 3.04. And then number 5, your natural log is right here, and your base 10 log is right here. So you get your natural log of 48. That is equal to 3.87. So really, no reason to miss those. Okay, they're just a plug and chug. All right, so now we're finding the inverse. So anytime you find the inverse, you're going to switch x and y. First order of business every time. And then you want to get your log by itself. That includes the log, the base, and then what you're taking the log of. So this 8 needs to go. Since I'm multiplying by 8, I'm going to divide both sides by 8. So I get x over 8 is equal to log, whoa, so log base y of 3. So the only way to get rid of a log with a base of y is to take y and raise it to that side. So if I'm going to take y and raise it to the log with a base of y, I have to do that to both sides. So now I've got y to the x over 8 is equal to 3. Well, this is kind of a problem because we want the y by itself. Okay? So we need to think, okay, to get y by itself, that would mean that I would have y to the first power. So I need to think about how I could manipulate this to get a y to the power of 1. Well, I know that anytime I multiply two inverses together, I get a 1. So in other words, if I did like 2 over 3 times 3 over 2, that's 6 over 6, which is 1. So if I were to multiply this exponent up here by 8 over x, and if I did that over here, I raised this to 8 over x, a power to a power, you multiply, and you just get 1. So I get y, but I'm going to say inverse notation, equals 3 to the 8 over x. All right, same thing here. Find the inverse. So I switch x and y. All right, so I have a power up here, and I know that if I'm taking the log of something with a power, I can move that power to the front. Oh, I'll have you guys here sitting here telling me, hey, you did that wrong. All right, so I pull that, and so I'm going to have x equals 2 times the log base 2 of y. Then I'm going to divide by that 2 because I want to get this log by itself before I try to cancel the log out. So I divide by 2. So x over 2 is equal to log base 2 of y. Now that I have my log completely isolated, I want to get rid of the log 2, so I need to raise it with a base of 2. So I've got 2 raised to the log base of 2 of y. And then the 2 log base 2 cancel. So I have my y by itself. I'm going to go ahead and put it into inverse notation. So I have 2 raised to the x over 2 power. Lots of 2's. All right, same thing here. Flip the x and the y. So I notice that I'm taking the log, the natural log, of this entire thing. All right, and so what I'm going to do is I need to get rid of the natural log. So I see that I just have the natural log of this stuff right here. So I'm going to take e and raise it to each side. And that's because I know that this natural log has a base of e. All right, so my natural log cancels. So I have e raised to the x equals y minus 4. And then all I have to do is add the 4. And I want to make sure that you guys understand this. I want to make sure that I know whether that 4 was meant to be up top or at the bottom. Some of you guys have been putting like really weird stuff, like putting the +4 at the top, okay? I need to make sure I know where to do that. If I can't figure out where you meant for it to be, then I'm just going to count it wrong, okay? I have to be sure, so make sure you're very clear and that your handwriting is neat there. All right, still finding the inverse, so I'm going to take and switch x and y. I see that my natural log is with what I'm taking the log of. There's nothing on the outside of that, so I'm going to go ahead and take e and raise it to both sides. And that's because my natural log has a base of e that I want to get rid of. So natural log with my e cancels. So I have e to the x is equal to negative 2x. Since I'm that's not an x. See? Every time. Y'all got to be careful about that too. You'll get to the end and have the wrong thing. All right. Divide by negative 2. And we don't like to keep the negative on the bottom, so I'm just going to put it out to the side of my fraction, or you can distribute it throughout the top, which in this case you only have one term, so that would be fine to leave it there. Okay, so expanding, that means I'm taking it apart and making it not simplified, kind of. So I know that if I have a root, that would be a fractional exponent, and a square root is raised to the 1/2 power. So then I can pull that 1/2 out in front. So I've got 1/2 times the log base 6 of a. And then multiplying by 1/2 is the same thing as dividing by 2. So I'm going to pull that down to the bottom, and I'm done. All right, same thing here, only this is a cube root. So I've got x to the 1/3 power, and then you're going to do the same thing. Pull the 1/3 to the front. But I don't like leaving that 1/3 out there. So instead of multiplying by the fraction, I'll divide by 3. So multiplying by 1/3 is the same thing as dividing by 3. And then I am done. All right. Expanding, same thing. This is the natural log of a to the 1/2. So if you take the same thing we've been doing, you pull the 1/2 down, that means you're just going to be taking and dividing by 2. Okay, now I'm taking the log of something that I'm multiplying, which means that I can split that into 2 logs that are being added together. And I'm done. Okay, now I'm condensing. So I noticed that, and that means you're just putting it all back together. So I want one single logarithm. You shouldn't have 2 at the end. So I'm going to take that 3, instead of pulling it down like when we were expanding, we're going to put everything back together. So I've got log base 4 of z to the 3rd. All right, and then dividing by 3 is the same thing as multiplying by 1/3. So I'm going to multiply by 1/3. And then I'm going to take that and put it back up to the exponent. So I've kind of already done this one. I'm just trying to get this other one simplified. So that means I've got log base 4 of x to the 1/3. But we don't keep fractional exponents. So a 1/3 power would be the same thing as saying the cubed root of that. So I've got log base 4 of the cubed root of x. So now I've got this log contained and this log contained. Since I'm adding the two logs together, that means I can multiply. So I'll keep the base of 4. And then I have z to the 3rd times the cubed root of x. Okay, so this one, I actually find this interesting because all three of them are being divided by 3. So technically, I mean, you could do each one separately, which is probably what you guys would do, so I'll do it that way. So I've got that, and then I've got another multiply by 1/3, and then I've got another multiply by 1/3. All right, and then I would take and put those in the exponent. So I've got log base 2 of x to the 1/3, and then I've got log base 2 of y to the 1/3, and then I've got log base 2 of z to the 1/3. So remember, a 1/3 power is the same thing as a cubed root. So I've got log base 2 of the cubed root of x, log base 2 of the cubed root of y, and log base 2 of the cubed root of z. Now, since I've got my logs fixed, they're all contained individually. I'm adding all of them, which means I'll keep the log base 2, and then I'm multiplying the cubed root of x times the cubed root of y times the cubed root of z. So technically, that's the cubed root of x, y, z. All right, still condensing, so I'm going to go ahead and raise this and raise this. So I've got natural log of 2 to the 20th, or that would be a big number, plus the natural log of 7 to the 4th. Since I'm adding these two logs, that means I can combine them into one and multiply. So this would be 2 to the 20th times 7 to the 4th. And those would be big numbers, so I'm fine with you leaving them like that. If it was like 2 squared times 8 squared, I mean, that'd be easier to do. All right, another condensing. So I'm raising. So I've got natural log of 6 to the 20th minus natural log of 7 to the 4th. So I have the natural log of, now if you notice, I really don't need this parentheses, I'm subtracting, so that means I need to take the first one divided by the second one. And you can put parentheses around that if you want to. It's up to you. Okay, so we are solving equations. So the first thing you want to do is you want to get your logs together if they're on the same side. So I've got a log base 7 of 2 plus a log base 7 of x plus 8. So remember, that just means that you're going to multiply these parts. All right, so you've got 2 times x is 2x, and 2 times 8 is 16. So now that I've got one log, I want to get rid of the log. So I'm going to take a base of 7 and raise it to both sides. It's very important. So my 7 log 7 cancels. I get 2x plus 16 is equal to 7 squared, which is 49. And now I just solve for x. So if I subtract 16, so I get 2x is equal to 33. All right, and then I'm going to divide by 2. So x is equal to 33 over 2. Now, since this is an equation, I've got to check my answer. If I were to take 33 over 2 and add 8 to that, that would still be a positive number. So I can log a positive number. All right, number 19. I have 2 logs that I am adding, so I will multiply to combine them. So I've got 2 times x is 2x, and 2 times negative 5 is negative 10. So in order to get rid of a natural log, I have to raise it with a base of e. Remember, because natural logs have a base of e. So this would be e to the first. All right, this cancels, so I have 2x minus 10 equals e. Then I just solve for x, so I add 10. So now I have 2x is equal to e plus 10. And then divide by 2. And you can leave it as one big fraction. I'm okay with that. You don't have to split it. And then you would check that. So you would take e plus 10, divide by 2, all right, and make sure that it works. And if you don't know what that is, plug it in. So I've got e plus 10, and remember e is right here. Second divide, plus 10 divided by 2 is 6.35, okay? So if I took 6.35 and I subtracted 5, that would still be a positive number, and I can log a positive number. Okay, so I have 2 logs here, and I know this kind of looks funny, but this is the log of negative 5x, and I'm subtracting. So I've got log base 4. So when you subtract the 2 logs, you're going to divide. I have negative 5x divided by 5 is equal to 3. So when I get rid of this base of 4, so I've got log, or 4, raised to log base 4 of negative 5x over 5. And 4 to the third power. So I've got negative 5x divided by 5 is equal to 64. And if you look at this, negative 5 divided by 5, that's just negative 1. So you could simplify that. And if you wanted to, you could have simplified it up here as well. So I'll divide by a negative 1. So x is negative 64. All right, again, 2 logs that I am subtracting. So I'm going to keep the base, and I'll divide x plus 2, always the first one, over the second one. Then to get rid of the log base 8, I'm going to take 8 and raise it to the log base 8 of x plus 2 over x minus 5. So over here I have 8 squared. And I apologize, you know how my pins are. So that cancels, so I have x plus 2 over x minus 5 is equal to 64. Okay, so I want to get this x minus 5 off the bottom, so I'm going to multiply by x minus 5. And since there's something over here, I'm going to have to make sure, all right, that I, put it in parentheses so that I can make sure that I know to distribute that, because sometimes we just tend to not do that and then we mess up. Okay, so that's going to cancel, and then I have x plus 2 is equal to distribute 64x minus 320. Then I just need to get my x's together and solve. So I'm going to subtract the 64x. So that's going to give me negative 63x plus 2 equals negative 320. So I'm going to go ahead and subtract the 2. So I get negative 63x is equal to negative 322. Then I need to divide by the negative 63. So I get x is equal to, and if you reduce that, you get 46 over 9. Okay, so you want to look up here, 46 over 9 minus 5, so you want to check that. That would give you 1 over 9, so that's not a problem. And then if I take and add 2, that's not a problem. So I'm good on that one. All right, now we're solving the equation, all right, without a log in it. So I want to get this part by itself first. So the part that's got the number raised to the variable power. So I'm multiplying by 6, so I want to divide by 6. So I've got 14 to the n equals 46 divided by 6. All right, and that doesn't divide evenly, so you just reduce it, so you get 23 over 3. Then I want to get rid of this base of 14 so that this can be by itself. So I do that by putting a log in front of it. So I have a log with a base of 14. Do the same thing over here, a log with a base of 14. So this cancels, so I just get n is equal to log base 4 of 23 over 3. All right, yet another one. Get this part by itself. So I'm going to divide by negative 2. So I get 4 to the x is equal to 85 over 2. That doesn't reduce. I want to get rid of this so that I can solve for this exponent. So I'm going to put a log with a base of 4 on both sides. That cancels, and x is equal to log base 4 of 85 over 2. All right, same thing over here. So I've got to subtract the 5 because I'm trying to get this part by itself. So I get 5 to the 3r is equal to 62. Now that I've contained that 5 to the 3r, I'm going to do with a log with a base of 5 so I can cancel that out. So log with a base of 5. So I get 3r is equal to log base 5 of 62. And then all I have to do is divide by 3. If you have a bunch of stuff over here, just divide by 3 once. Like just put it all over 3. I'm not asking for, you know, you just split it up and stuff like that. Just leave it as is. Okay, so now I've got negative 28 e to the negative 5r. So I need to divide by negative 8. So I get e to the negative 5r is equal to just 93 over 8. That doesn't reduce. To get rid of an e, I need to natural log both sides because that has a base of e. So I have negative 5r is equal to the natural log of 93 over 8. And then I just divide by negative 5. But remember, we don't leave negatives in the bottom. So I'm just going to stick it out to the side up top. If I had multiple things up top, I would have to change the sign of all of them. All right. So I am solving for this up here. So I need to get this whole thing right here by itself. So the first thing I'm going to do is subtract the 6. So I get negative 10 times 4 to the 2b plus 10 is equal to negative 78. Then I'm going to divide by negative 10. So I get 4 to the 2b plus 10 is equal to negative 78 divided by negative 10, which reduces to 39 over 5. Now that you've got that base with the exponent, you know, isolated, you're going to log both sides with a base of 4 so that that will cancel. So I have 2b plus 10 is equal to log base 4 of 39 over 5. And then I solve for b, so I subtract 10, and I'm just going to do this in one big step, and then divide by 2, so you get all of that over 2. Like I said, you don't have to split it or anything like that. Okay, last one. So you're going to do the same thing. You're getting this by itself, so you're going to have to add 6 first, and then divide by negative 2. So I'm going to add 6. So I get negative 2 times 3 to the 7b plus 5. So if I add 6 to this, that's negative 57. And then I'm going to divide by negative 2. That won't reduce, but it will simplify to 57 over 2. So now I've got that isolated. I'm going to log with a base of 3 on both sides. That cancels. So 7b plus 5 is equal to log base 3 of 57 over 2. And then I'm going to do the same exact thing that I did the last time. To solve for b, I've got to subtract 5. And then I have to divide by 7. Just put it all over 7. And for your bonus, you will have some piecewise functions. So don't forget about those.